Hi, I'm Nova Spivak, CEO of Twine.com, and in this screencast, I'm going to give you a short preview of one of the developer tools that will be launching as part of Twine 2.0 at the end of this year. This screencast is geared towards developers or people who are interested in the technical aspects of Twine and the semantic web. If you're interested in the consumer experience of Twine version 2, please see my other screencast on that topic. An ontology is like a database schema. It defines a set of concepts or data types related to some domain of interest. There are a number of ontologies that already exist, and they're defined in many cases with open standards languages like RDF and OWL, which are the languages of the semantic web. Here, our tool has pulled in a number of different popular ontologies. The DBpedia is an ontology that's similar to the Wikipedia. The Dublin Core is an ontology that describes library data. Friend of a friend defines social networks and social profiles on the web. iCal describes calendars. RSS describes RSS, and here's an ontology we authored about food. Let's go look at it, the Twine Food Ontology. So this ontology has a number of different classes and properties related to food, things like recipes, cuisines, menus, restaurants, and other concepts. Here we can go in and look at all the different concepts in the ontology: cookbooks, cooking implements, dining establishments, and so forth. Well, let's drill in and specifically look at recipe. Within a recipe, there are a number of different properties that have been defined. Things like an author, who authored the recipe, a cook time, the amount of cholesterol it has, the number of calories it has, and so forth. These different properties can map to different types of data, whether strings or numbers, or even other classes in this or other ontologies. So let's go look at author, which maps to the author class, which describes the author of something. An author is a kind of person with various other properties that describe this role of being an author. Now, there are many different ontologies that we've pulled in. In fact, we can handle any standard ontology in RDF or OWL. But in addition, you can author ontologies. So this lets you author and collaboratively author ontologies in a manner that's very similar to SourceForge. SourceForge is a tool that lets people collaborate to develop open source software. In this case, whether the ontology is open source or not, we allow people to share it and collaborate to help make it better. Once an ontology has been developed, data can then be linked to it all over the web, simply by referring to the concepts in this ontology. And once an ontology is linked to that data, it serves as metadata, which makes that data understandable. So any application that can speak RDF or OWL, which sees that metadata on the web, can then figure out what the data means and make use of that data in an unambiguous manner, the manner in which it was intended. So this is really important, because if you want to make the web function like a big database, you need a standard schema language to define what the data means. Not just how it's structured, but what it means. So for example, if you want to make a resume, you can mark it with metadata that says it's a resume. And if in that resume field there's something which describes professional experience, you can mark it as such. And that enables other applications to correctly interpret that data. The key here is that this is all using open standards, and it's very easy to use. You don't have to know RDF or OWL. You don't have to understand any fancy semantic web concepts. It's all point and click, and it's hosted on the web. There are many other tools for creating and sharing ontologies, but they're very sophisticated. Often they're geared towards extreme cases where a lot of reasoning is required, and they're very hard to learn and figure out. Here, we wanted to make a tool that was incredibly simple, that any webmaster could use. In fact, even people who aren't webmasters, who simply are domain experts in various areas of knowledge, could quickly model their knowledge domain, and then other people could start to use that model to connect data to it. Once data is connected to an ontology, it can be understood by any application that speaks RDF or OWL, including Twine. So the idea here is that if you have a website and you want to make that site understandable, you can link it to one of these ontologies, or you can make a new ontology if there isn't one already. Now, if your website already has RDF or any other kind of metadata in it that Twine understands, you don't need to do this. We can just index it automatically. But there are lots of verticals or types of sites where maybe no ontologies exist and maybe there's no metadata, and this makes it very easy to link those to the semantic web. So this is really like SourceForge for the semantic web. It's just one of many tools that we're launching as part of the Twine version 2 architecture. The goal is really to transform the web into one giant database. This is really the dream of the semantic web, which Tim Berners-Lee came up with many years ago. And finally, it's starting to become a reality. There are many companies working on different pieces of this, and we're not the only one. But we hope that this will be a useful contribution to the overall tool set that everybody's starting to use. This is just a brief preview, and I don't have time to go into all the features and other tools we have. But as we get closer to launch, I hope to provide more information. Again, if you're interested in the consumer experience, please see my other screencast. Thanks a lot.